Hello everyone. So today we'll start with the topic that is Bayesian Belief Network. So in this video lecture, we'll study how the problems can be solved using the Bayesian Belief networks. So we'll discuss a solved example which will give you a clarity of how to solve the questions of Bayesian Belief networks. So first we'll have a little introduction about what are belief networks and then we'll move on to the numerical part of the question. So as we have already discussed in one of our videos, a Bayesian belief network is a graphical representation which is made up of arcs and nodes. Now these are the directed links which basically denote the relationship between the nodes. So here we can see we are given a graph in which the nodes are A, D, C and B. So these are the nodes. We have 4 nodes and we have different directions which are associated with the nodes. So these are known as the links. So we can see A is linked to D and A is also linked to B. Similarly, C is linked to D and it is also linked to B. So these are the graphical representation which helps us to denote or define the relationship between the different nodes. So next, in this slide, we have written what we have already discussed, like what are the nodes, what are the variables, and how these nodes are connected with the help of causal relationship. So you can see the relationship was shown in the previous diagram. So in that diagram, we had A, B, C, D as the random variables, which were represented by the nodes. Second, we also discussed the relationship between the nodes, which is denoted by the directed arrows, and it is also known as a link. So here we have already written the discussion of the graph, which we have did in the previous slide. Next, for solving the numerical part, we should know what is a joint probability distribution. So in case of graphical representations or in case of nodes where we have some links associated with different other nodes of the graph, we need to calculate the joint probability. So whenever we are given with the numerical of Bayesian belief network, we have to calculate the joint probability distribution. So there is a formula for calculating the joint distribution. So in this we can say we are given the probability for different nodes like D, S, A, B and E. These are the nodes in a graph. Now how do we calculate it? You can see from this equation, this is the derivation for joint probability distribution. The first node, that is D, is written over the numerator, and in the denominator we are writing all the other nodes like D and then S, A, B, E. Similarly, we'll start with the next one, that is S. So we are writing P, S is. Now we will write all the remaining like S, A, B and E because D is already in the numerator. So this is the derivation, or how we can expand this derivation to derive the formula. So at the end, we'll get P D by A into P S by A into P A by B, comma E, P B by E and P E. So this relationship is basically defined from the graph which is given to us. In that, will get to know what are the links between the nodes, so we can easily derive this expression. So this will be very clear in the numerical part. I'll show you how this equation is derived from the graph. You just need to know this is the joint probability distribution. Rest we'll discuss in the numerical part. So I hope this is clear to all. So next, this is the problem for solving the Bayesian belief network. So the numerical which is given to us states that we have to calculate the probability that an alarm has sounded, but there is neither a burglary nor an earthquake, and David and Sophia both called Harry. So from this problem, we can see what are the basic events. So alarm is an event which has sounded or not. Next, but there is neither a burglary. So burglary is also an event which can occur or not. Next, the event is earthquake, because in this it is given the earthquake has not occurred, nor an earthquake occurred. Next is David and Sophia. So these are also nodes or events, but David and Sophia both called Harry. So this is the next event. So we can see we have 1, 2, 3, 4, 5, 6, 6 events for which we have to calculate the joint probability distribution. Basically, whenever we are solving this problem, we are given a graph and also the probability distribution, or we can say the tables for the different event, which will state the probability of the events. So this I have already discussed. We are given with 6 events: burglary, earthquake, alarm, 5 events, earthquake and Sophia. Now this is the graph which will be given to us. We can calculate the probability, or sometimes it is also given for the numerical questions. So burglary is an event, earthquake, David, Sophia and alarm. Now these are the 5 events. We are also given with the relationship between the nodes, like alarm is dependent on burglary, alarm is dependent on earthquake. But David and Sophia, we can say the alarm gives the response to David and Sophia. So this is the graph, but here we are also given with the probability of the events, like true or false, like burglary has happened or not happened. So here we have only one event, that is burglary 1. So we will have only two combinations, like true and false, because whenever one event is there, the outcomes will be 2 to the power 1. That is two possible outcomes, true and false. Similarly, earthquake is an event, which is the second event, and here it is also one event like earthquake. So it will be only having two outcomes, true and false. But for this third condition, alarm is dependent on two events like B and E. Alarm is dependent on burglary also, and alarm is dependent on earthquake also, because there is a directed graph which is showing the relationship of alarm with burglary and earthquake. I hope this is clear. Now you can see why this A table is having 4 combinations, because we are we can see from the graph A is having burglary and A is dependent on earthquake. So two, whenever we have to calculate the probability outcomes, 2, and it is dependent on how many events. This is the formula, 2 to the power n. So 2 alarm is dependent on 2 events like 2 to the power 2. So we will have 4 combinations of the possible outcomes. So you can see one table is written over for B and next is for E, entry for B and E. So possible outcomes can be, first it is true, false, true, false, and here it can be true, true, false, false. You can check both the events are true. One is true and one is false. One is false, next is true, and both are false. So similarly, we have the table for this combination where these both values are true and alarm is also true. But when alarm is false. So this is the probability table for alarm, third event. Next, we have the fourth one, that is David. Now here we are given with two values, like it is dependent, D is dependent on alarm. Okay. So alarm, it is dependent on alarm. So we will have two combinations only for A and T. But D can be true also and D can be false also. But in the previous, it was not dependent on because burglary was dependent on alarm. But here, David can be, David can call also and David cannot call also. So we'll have D as true and D as false. So here we'll have different combinations of A for D and D is false. Similarly, here Sophia is dependent on alarm. So alarm will be the condition for which we'll be writing the outcomes true and false. But Sophia can call also and Sophia cannot call also. So this is also the probability which is given to us. I hope the table is clear to everyone why the table table is having different outcomes. So next, now we have to find the solution for the given problem which was stated in the previous slide. So here we can see now from the formula of joint probability distribution, we can write the probability problem statement in the form of probability distribution. So from the question, we can see that alarm has sounded. So we are writing alarm has sounded as S. Or we can say we are having these four events B, E, A, D, and S. So we can write it in any form like S, D, A, B, and E. Now we have different events. David and Sophia both called. Okay. So I hope this is clear why we are writing this as Sophia and D because they both have called. Next, alarm has sounded. So alarm is also positive because we are talking about the event it has sounded. So S comma D comma A. You can write it in any sequence. It is not compulsory. In this, I have written all the positive events together and then the negative events later on. So from the diagram, we'll see SDA. Next, we had neither burglary nor an earthquake. So these both events are negative. So we are writing at SDA, B, negation of B and negation of E. I hope this is clear. Now, how we'll derive this expression? So first, we can see S is dependent on A. So we'll write S by A and D by A. I hope this is clear. S by A and D by A because these were the events that were positive. Okay. Now S by A is written into D by A and we are writing P A upon negation of B and negation of E because the graph itself says that A is dependent on B and E. But these both events are negative. But without the combination of B and E, we cannot find the probability of A because in the table also we can see this is B and this is E. So what will be the condition for the next one? That P A upon negation of B and negation of E. Let me move on to the later slide. Next slide, you will get to know. So you can see P, I hope this is clear to all. S by A, D by A negation of A upon negation of B and negation of E because these are the events which were in the negative form or the conditions given were in the negation. Similarly, we have written into P negation of A, B into P negation of E. So let me move on to the previous slide. So you can see why we are writing because alarm is dependent on both the conditions B and E. But similarly, burglary is also an event and E is also an event. So we will also write the joint probability of both the events. So we can see from the graph, first we have written for D by A, this relationship, then for S by A, then for A, which was dependent on both these conditions or events, and then the last event that was B and E. But since these events were in the negation or negative form, so we have written the equation in this form. So I hope this is clear how we are deriving this expression for the Bayesian belief problems. So you can see the last one, that is P. Now you can easily understand why we have written S by A, D by A into P negation P A upon B and E, then simply B negation of B and P negation of E. Now from the table, we'll pick the probabilities of the event. So for first event, we have that S by A. So from this table, we can see what is S by A. So S by A is this one, where S is true. S by A, because the event A is positive, it is not negative. So the probability is 0.75. So similarly, we can see we have written here 0.75. Then for this one, PD by A. From the table, we'll see what is PD by A. So from where will PD by A is this one. P D by A, because A is positive. So the value will be 0.91. So you can see the value we have written is 0.91. Next we have the third one, that is P A upon negation of B and negation of E. So here we'll be checking the condition of A when the value of B and E is negative. When the value of B and E is negative. A. So we'll move on to this one. A, when the condition for when the value of B and E is negative. So from the out value, we can see the value is this one, that is 0.001. Okay. Next, we have the probability for this one, that is P negation of B. So P negation of B is negation of B. That will be 0.998. Then we have P negation of E, that is 0.999. You can see from the table, that is 0.999. That is P negation of E, which is written over here. So I hope this is clear. But in this case, we were having a value that was P and B by E. So how we'll calculate this value? We can calculate the value by multiplying the probability A for negative E and negative B. So negative E is 0.999 and here the negative B is 0.998. When we'll be multiplying it, it will give us a value of something like 0.001. So finally, we'll multiply all the values and we'll get the outcome as 0.0068. So this is the probability for the different events which were calculated using the joint distribution. So I hope this is clear to everyone. Thank you.